Welcome, everyone. All right, let's just dive straight into this. Today, we are tackling what I like to call the absolute ultimate Cambridge Mathematics Challenge. We're specifically zeroing in on navigating the really tricky terrain of syllabus 0580. Now, I want you to imagine an absolute wasteland of complex exam questions. You know the ones specifically designed to trip you up and make you second-guess everything. Well, that is exactly what we are conquering today, so you can claim your grade treasure. We are going to be acting as mathematical detectives. Think about it. You see, most students are taught how to take a nice, neat equation and just plot it out on a graph, right? You plug in the numbers, you draw the line. Simple. But what happens when Cambridge completely flips the script? What happens when they give you the graph and ask for the equation? It's a completely different ballgame. Suddenly, you have to reverse engineer the math from purely visual clues, and let me tell you, that requires a completely watertight strategy. You can't just guess your way through it. So the crucial question we have to ask ourselves is this. If a graph is essentially just a photograph of an equation, how do we reverse the camera? How do we look at that picture, that curving line on a grid, and figure out the exact algebraic DNA that created it? Well, today's explainer completely flips the usual script. Instead of drawing a graph from an equation like you normally would, we are going to use specific visual clues, things like intercepts, vertices, and asymptotes, to literally unmask the true identity of the function. It is all about decoding the shapes. And once you learn how to read those shapes, it's actually incredibly satisfying. It's like seeing the matrix. Okay, here is our case file for this session. Section 1, the function identity parade. Section 2, linear and reciprocal suspects. Section 3, cracking the quadratic code. Section 4, catching the cubic curve. And finally, Section 5, solving the case. Let's get into it. Act 1, the function identity parade, where we profile our suspects. Now, before we look at the actual math, let's look at two incredibly common exam archetypes. I guarantee you know these people, or maybe you've even been one of them. First, we have Alex. Now, Alex overloads his paper with raw mathematical facts. He just throws every formula he knows onto the page, but there's absolutely zero visual analysis. He's not looking at the clues. Then, on the other end of the spectrum, we have Sam. Sam panics. He rushes, completely misses the command words, and just starts plugging in the wrong coordinates entirely. Both Alex and Sam lose massive marks. Why? Because they lack a structured, reliable framework. They're just throwing spaghetti at the wall to see what sticks. So how do we fix the mistakes made by Alex and Sam? We apply a framework, specifically our Peel-inspired framework, which we've adopted directly for Cambridge Mathematics. Point, evidence, explanation, link. Here's how it breaks down into 3 simple steps. Step 1 is the point. You need to identify the shape's general mathematical form just by looking at it. Is it a straight line, a parabola, hyperbola? You have to know the suspect before you interrogate them. Step 2 is the evidence. You extract a known xy coordinate directly from the graph. You find a point where the line crosses perfectly on the grid. Then, step 3 covers explanation and link. You substitute those values into your general form to solve for the unknown coefficients, your A, B, C, or D. And then you link it back to state the final, polished equation. This right here? This is exactly how top-tier students structure their mathematical investigations. It literally turns chaos into a simple, reliable 3-step checklist. Now, mastering frameworks like Peel definitely takes practice. You can't just hear it once and be perfect at it. So before we go ahead and profile our first specific functions, make sure you subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Seriously, click that subscribe button and hit the bell icon right now so you don't miss any of our upcoming strategy guides. We've got a lot more coming. All right, let's move right into Section 2, linear and reciprocal suspects. This is where we build our foundation. We are bringing in the 2 simplest suspects in our identity parade today. Think of these as your entry-level interrogations, okay? If you can master these, you set the baseline for the really complex curves coming up later. Let's contrast our 2 base forms. On side A, we have the linear function. Its true algebraic identity is always f of x equals ax plus b. It represents a perfectly straight line where a is your gradient or your slope and b is your y-intercept. It's the straight shooter, no tricks. On side B, we have the reciprocal function. Its form is f of x equals a over x. Visually, this is a hyperbola curve. It's that really distinct shape that approaches the axes but never actually touches them, assuming a is not 0, of course. By simply memorizing these 2 visual profiles, you literally eliminate half the work before you even touch your calculator. You look at the paper, see a straight line, and boom, your brain should immediately scream ax plus b. Let's look at a concrete example directly from our source material. Imagine a straight line passing through the coordinates 0, 4, and 2, 0. Remember Alex from earlier, the guy who overcomplicates everything? Alex would write pages of algebra trying to force some complex polynomial here. He'd be sweating over it. But using our framework, we instantly recognize the straight, linear shape. So, step 1, the form is definitively ax plus b. Step 2, extract our clues. The graph gives us 0, 4 and 2, 0. Step 3, we calculate. The gradient a is just the change in y over the change in x. So, 0 minus 4 divided by 2 minus 0. That gives us negative 4 over 2, which equals negative 2. Great. And the y-intercept? It's literally screaming at us right from the coordinate 0, 4. Since x is 0, b is just 4. Put it all together, and f of x equals negative 2x plus 4. Just like that, in a matter of seconds, Alex's frantic red pen marks transform into solid, confident green check marks. Now let's apply this exact same logic to our other suspect, the hyperbola. We know the form is f of x equals a over x. Let's say the graph shows it passing through negative 5, negative 1. Now Sam, our panicker, would completely freeze up here. Negative numbers, a curve, he's done. But you? You know step 2 is just substituting the evidence. You substitute y as negative 1 and x as negative 5. So you get negative 1 equals a divided by negative 5. Multiply both sides by negative 5, and the algebra is incredibly simple. Negative 1 times negative 5 means our unknown a is simply exactly 5. The final equation is f of x equals 5 over x. Boom, a potentially confusing graph decoded in 10 seconds flat because we followed the framework. All right, great job. We've cleared the entry-level stuff. It is time to escalate this session to the mid-level boss. Section 3, cracking the quadratic code, interrogating the parabola. This is where the Cambridge examiners really genuinely start to test your analytical stamina. The shapes get bendy, the equations get longer, and the traps get trickier. But before we take on this boss level, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Listen, we've helped thousands of students improve by 2 to 3 full grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Trust me, you'll want the notifications on for what we have planned next week. Okay, let's dive into the mathematics success blueprint specifically for quadratics. A parabola is that classic U shape, or an upside-down U, and its absolutely most critical visual feature is its vertex, the absolute lowest or highest point of that curve. Our source material reveals a brilliant shortcut here. If you spot a vertex at coordinates hk on the graph, you immediately skip the long standard form and use the vertex form f of x equals a times x minus h squared plus k. For example, if a graph clearly shows a vertex at the point 3, 6, your equation instantly starts as a times x minus 3 squared plus 6. You're already 80% done. Then, if they give you another clue, like a y-intercept of 0, 15, you just plug in x equals 0 and y equals 15 into that exact equation to find your missing a value. It's beautiful. It maps the visual directly to the algebra. There is absolutely no guessing required. Now let's put you to the test with a 60-second mental challenge. We have a quadratic, and we are told the a value is 1, so the form is just x squared plus bx plus c. Clue 1, the vertex is at p4, and we know p is positive. Clue 2, the y-intercept is at 0, 13. Your mission, find the value of p. How do we extract this core trend? Well, think about our blueprint. Because it's a standard x squared, our a value is just 1. So using that vertex form we just learned, the equation is f of x equals x minus p all squared plus 4. Now imagine expanding that out in your head. You'd get x squared minus 2px plus p squared, and then that plus 4 hanging on the end. So the constant term, the part with no x attached, would be p squared plus 4. And what do we know about the constant term in any polynomial? It is always the y-intercept. And clue 2 says our y-intercept is 13. So if p squared plus 4 equals 13, that means p squared must be 9. And since the problem stated p is positive, therefore, p is exactly 3. If you followed that logic, honestly, give yourself a pat on the back. You are well on your way to an A star. Let's take a quick mental breather right here. That was intense, I know. Just look at these points illuminating the wave on the screen. I want you to burn this rule into your memory. More curves mean more intercepts, and more intercepts mean more clues. As we move on to the highest tier of functions, the ones that look like roller coasters, do not let the extra bumps and dips intimidate you. Every single time that curving line crosses an axis, the examiner is handing you a free piece of evidence to solve the case. They are literally giving you the answers if you know how to look for them. Which brings us perfectly to Section 4, Catching the Cubic Curve. This is it, the mastermind function, the final boss of the O580 graphing questions. It takes the slightly terrifying form of f of x equals ax cubed plus bx squared plus cx plus d. 4 unknown variables. It looks like a nightmare. But remember our mantra, more curves equal more clues. Let's run a 30-second speed writing workshop challenge. Look at this mastermind problem pulled straight from the source text. We have a cubic suspect. F of x equals x cubed plus bx squared minus 11x plus d. Okay, so a is 1 and c is negative 11. We need to find b and d. Our visual evidence? Clue 1. It intercepts the y-axis at 0, 12. Clue 2. It intercepts the x-axis at 4, 0. Your goal is to find those missing values, b and d. Look really closely at those 2 clues. Which variable can be solved instantly, right now, without any complex algebra? If you remember the Peel framework, you will always look for the easiest evidence first. And here is the examiner commentary and the absolute perfect response. You substitute x equals 0 first. Why? Because every other term has an x in it, which means they all just vanish. 0 cubed is 0, b times 0 squared is 0, negative 11 times 0 is 0. You are left with just d. And since clue 1 tells us y is 12 when x is 0, d instantly equals 12. No stress, no crazy equations. Now you update your working equation. F of x equals x cubed plus bx squared minus 11x plus 12. For the final step, you substitute the second clue, where x is 4 and y is 0. So 0 equals 4 cubed, which is 64, plus b times 4 squared, which is 16b, minus 11 times 4, which is 44, plus 12. Let's simplify that down. 64 minus 44 is 20, 20 plus 12 is 32. So you get 0 equals 32 plus 16b. Move the 32 over the equal sign, so negative 32 equals 16b. Divide both sides by 16, and b equals negative 2. The final, perfect, full marks equation is f of x equals x cubed minus 2x squared minus 11x plus 12. Mastermind completely defeated. Incredible work. Let's move to Section 5 and solve this case once and for all. We have profiled the linear straight shooter. We've interrogated the reciprocal and the quadratic, and we just defeated the cubic mastermind. Now it is time to consolidate everything we've learned into your ultimate cheat sheet for Cambridge math success. Here are the 3 non-negotiable rules that guarantee top marks and form your complete answering system. Rule 1, command word decoding. Always know exactly what the question is asking before you write down a single number. Rule 2, the Peel framework application. Point to the shape to know its form, extract the visual evidence, explain via substitution, and link back to state the final equation. Rule 3, the time management matrix. Do not rush and plug in the wrong coordinates like Sam, and please do not overload the page with irrelevant formulas like Alex. Be precise, be surgical. Students who actively implement these exact 3 strategies see an average improvement of 2 full grade boundaries. Let that sink in, 2 grades. But, as always, that only happens if they practice consistently. And that leads perfectly to our final, crucial step. Here is your final reminder. Subscribe to our YouTube channel AC Exams at acexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acexams_IGCSE and click that bell. Don't let another exam pass you by while you're still using the wrong strategies. Right now, I want you to drop a comment below with your specific target grade for mathematics and tell me the biggest challenge you're facing right now. Seriously, type it out. Our team genuinely reads and responds to every single comment because we want to help you get there. Also, make sure to like and share this explainer with a study partner who needs this exact strategy. Don't keep it a secret. Ace the Exams, your Cambridge success starts here. As you prep for your next past paper, I want you to ask yourself, are you just blindly memorizing formulas, or are you actually learning how to read the hidden stories inside the graphs? Keep analyzing, stay focused, and I'll see you in the next session.